Welcome to this new demo of Java under the hood, in which I will demonstrate the use of method parameters of a primitive type. The code I'll be demonstrating consists of this class with two methods, the main method and an additional add method. And the purpose of this add method is, well, to calculate the sum of two parameters x and y. The main method starts by initializing three integer variables, after which the method add is called, where we pass as arguments the number 1 and number 2 integer variables to the x and y parameters. So the add method returns the sum. The return type of the add method is an integer, and when we come back from the invocation, we assign the result to the sum variable, after which we can print it out. What we'll see in this demo is that parameters are stored on the stack. Let's have a look. So here we have the memory layouts, and as explained in the previous demo, the local variables array contains, first of all, the arguments parameter of the main method. Now, this parameter is of no further importance in this demo, but I mention it in order to make the picture complete. Let's focus now on the declaration of the variables. As explained in the previous demo, when we declare a local variable, it is stored in the local variables array, but at a subsequent position after the parameters. Int number 1 is assigned to a value of 3, and so the value of 3 will be stored in number 1. Int number 2 gets a value of 4. And then the third variable in sum gets a value of 0. What I'm going to introduce here is a concept of a current stack frame. Actually, I could have done that in a previous demo, but as stack frames are related to methods, and this demo is about methods, I think this is a better place to start talking about it. So what is a stack frame? It is a construction in memory, which is created each time a method is invoked. And for each method, we get a separate stack frame. Since main is the first method that is executed, a stack frame for this method is created. Which we see here, this is a stack frame of the main method. Now, what does a stack frame contain? First of all, the local variables array, but more than that, namely an operand stack and a reference to the current class constant pool. Now, those two I'm not going to explain here. What I will demonstrate, however, is that the current stack frame stores the return value of a method as well. Whenever we invoke a method, the Java runtime environment jumps to the implementation of the add methods. Since this is a new method, as explained, what is created next to the stack frame of the main method is a new stack frame, but this time for the add methods, where it'll store its local variables and parameters, if there are any. In this case, the parameter x will get the value of number 1, which is 3. X variable is allocated and it gets the value of 3. For number 2, passed to y, we get the similar story. So added to the stack is the y variable, which gets the value of number 2, which was 4, and that value is assigned to y. And those two parameters are thus stored in the local variables array. Now, this method doesn't have any other local variables, so these two are the only variables that are stored in the local variables array. When we continue the execution of the add method, we need to return the sum of x and y. So 3 plus 4, and that is stored in the stack frame as well. So we have the local variables array that consists of, at the first position with index 0, the x variable that has a value of 3. At the second position with index 1, the y variable with a value of 4. And next to the local variables array, we have the return value of the methods, and here it has a value of 7. Now, 200, 250, these are fictional numbers. It's just to illustrate that this stack frame is located at a different location in the entire stack memory. So separate from the stack frame that was created for the main methods. Important to note is that parameters, so x and y, contain copies of the original values that were passed to them. Whenever we would assign a different value to the x value, so assume that before the return statement we do x++, this would result in x having a value of 4. Well, that doesn't have an impact on the original argument that was passed. So number 1 isn't influenced by that. So parameters are copies. Let's examine now what happens when we return from the add methods. So the return takes place, we leave this method, and the return value of the add method must be assigned to the sum variable. This will happen now. Okay. The add method is no longer executed, so the stack frame associated with it will be removed from memory. And we are back at the stack frame of the main method, which becomes now the current stack frame. If we would print out the value of sum, we would see the value of 7 appear. If you want more information about stack frame, I suggest that you go to this link of the Oracle specification. Some things we can read in that article are that a frame is used to store data and partial results as well as return values for methods. So data and partial results, these are the parameters and the local variables we just discussed. A new frame is created each time a method is invoked. So we had a stack frame first for the main method, then we invoke the add method for which a new stack frame is created as well. And a frame is destroyed when its method invocation completes. Each frame has its own array of local variables, its own operand stack, and a reference to the runtime constant pool of the class current methods. And finally, only one frame, the frame for the executing method, is active at any point. This frame is referred to as the current frame, and its method is known as a current method. So in the beginning, the current frame was that of the main method, and that was the current method. We invoke the add method. Current method becomes the add method, and the current frame is that of the add methods. Okay, that's for my demo. Bye bye.